What follows is a brief clip from my interview today with David Margulies. He is a PhD STEM professional and parent in California, and today he's speaking out about the California Draft Math Framework, which he's concerned will hurt kids who want to be in STEM careers, like he is. He sees it as a one-size-fits-all solution that is following research that just doesn't add up, and he will explain that a little bit in this clip, but I hope you will be inspired to watch the entire interview and learn for yourself why this framework fails STEM students. I also hope you'll be inspired to write a public comment during the public comment period, which ends on the 16th of May. You can find a link to make a public comment at savemath.net right off the homepage. Thank you for watching.
Okay, so there's certain things here that the framework's doing that I'm going to address in this talk. And so one is it's going to guide for a one-size-fits-all approach to math classes and students until 11th grade. So that means that students are placed in the same class until then, regardless of their preparation, motivation, and ability. And so the way this is phrased in the framework, so here's a quote: "This framework recommends that all students take the same rich mathematics courses in kindergarten through grade 8. For high school courses, pathways for high school coursework reflecting a common 9th and 10th grade experience." And so what this ends up meaning is students who need more support are grouped with students who are ready to advance, along with all students in between. So it's one size fits all to math until 11th grade. And then a consequence of this is that the taking of Algebra 1 is going to be delayed until 9th grade. And a lot of students take it in 8th grade and earlier. 25% of the kids in the United States take algebra in 8th grade. So it affects a lot. This would affect a lot of kids. And then so it adds a new course called the MIC3 we'll discuss. The framework guides to removing standards-based instruction. And then a big problem with this framework is that it seriously misrepresents the citations that it quotes from. Okay, so to go on just qualitatively what schools do now in terms of math as a function, math courses as a function of grade, it's shown schematically here. So basically the top course pathway is how students get to AP Calculus. So they start with Algebra 1 in 8th grade, Geometry 9th, Algebra 2 10th, Pre-Calculus 11th, and then they get to AP Calculus. And then there's a second course pathway. It's called the Integrated Math 1, 2, 3 courses. And these are essentially a rearrangement of the content of the Algebra Geo Algebra course pathways. So they cover the same content, just in a different order. So they're really essentially to first order the same pathways. Okay, so then qualitatively, what the framework is doing is shown below. So they have a common experience for all students for 9th and 10th grade and all students in the same classes in middle school. So what this means is students start with Algebra 1 in 9th, and then, so then what do they end up with when they hit 12th grade? Because if they wanted calculus is a 5-year sequence, and you can't do that in 4 years.
Right. What about the kids? I'm also wondering, what are the kids in 8th grade doing? As you mentioned, there's 25% of the kids right now who take Algebra 1 in 8th grade. So I assume the 75% are still doing whatever in 8th grade, but those 25% are doing what? Twiddling their thumbs? I mean, how bored must they be?
That is a huge concern. Absolutely. Yes. Yeah. No, and that's a sad thing that the people doing this don't seem to be that concerned about the well-being of that particular group, because they're, I guess, we can disregard them for maybe the benefit of the whole or something. It's unclear what they're thinking with respect to that.
Right. And yet they'll say things like, this reduces inequality. It helps everybody have, there's more equity in this plan. And I can see how it's more equity downward. You're denying acts, or literally taking the box away from the little kid standing in front of the baseball field, right? You're actually taking a box away or digging a hole underneath his legs so he's at the same height as everybody else. But what are we losing because of that? What is the child individually losing in terms of just even being remotely happy at school? And if you're really good at math and you just can't move ahead, and then what if their parents are super motivated and say, you know what, forget about it, we're going to do it privately. They are still going to get ahead, but now the other kids in the school don't have that same access. So you're perpetuating the inequality, actually.
Right. You're exacerbating it, really, is what's happening with this framework. A first thing that I really wanted to address is, now if we're going to consider removing this path to calculus, let's understand clearly why it is that districts have this available to their students. Why is it that taking calculus in high school can be beneficial? Why is it that the Common Core state standards say that this is a good and worthy goal? And so it's not just about college admissions, although this is very important because these students will be surrounded by students who have taken calculus. But basically, the mathematic principles learned in calculus are foundational to the upper level studies in STEM majors. And so for this reason, calculus sequence is a required sequence for the beginning of STEM majors. And so here's a quote from the framework where they're talking about calculus in high school. And they say, as is sometimes expected for many STEM majors. And so what I wanted to do is, well, let's look at this in practice. What does this actually really mean? Now the experimentalist nature of myself got the better of me, and I really wanted to say, well, how many of these majors really do start with calculus? Let's really take a look at it. So I decided to go through all the majors at UCSD and then make this table. And so what I found is there are 78 majors that start with a required calculus sequence. And so these majors, they fall in 16 different fields, and these fields are bioengineering, biological sciences, chemistry and biochemistry, cognitive science, computer science and engineering, data science, economics, electrical and computer engineering, global health, mathematics, mechanical and aerospace engineering, nanoengineering, physics, psychology, oceanography, and structural engineering. So there's basically a great breadth of fields that require a calculus beginning. And the reason for this is because it's foundational in the upper division studies that follow. And so what I found is that at least at UC San Diego, all STEM majors require a calculus starting sequence. And again, the majors that require calculus are from widely different. We have economics to psychology, biological sciences to data science, oceanography to chemistry. So we're not just talking engineering, math, and physics. So if parents think, oh, I only need calculus for those, no, not at all. You're greatly limiting yourself if you're not prepared for that. And that's why I came to this point that what the framework says, as is sometimes expected for many STEM majors, right? So more accurate, or far more accurate, as is always expected for all STEM majors. And so part of what I just mentioned is recognized in this open letter that's signed by these STEM professionals. So here's a quote from it, and they mention that students who spend their early years taking introductory math courses may require more time to graduate. They may have to give up other opportunities, and they may be more likely to struggle academically. And then the bottom one as well comes from that because it opens up internships and research opportunities. So they recognize these. And so these benefits are tangible and significant. The last part I wanted to mention about calculus in high school comes from this study, which looked at 6,000 students, and it looked at how they did when they took calculus in high school and then took it again in college. And so this was a very careful and detailed study. And so one of the points they start off making is, again, so that a college calculus class is a step up in rigor from a high school calculus class. So it's not like you're retaking the same class. You're taking a class with a step up in difficulty. They especially they say expectations and at the level of practice standards can be very different. And so what they find, like, the measurements, they go through and actually analyze all the data. They find that the students who took calculus in high school end up with a higher grade than the students who did not. And they find that students with relatively weak backgrounds appear to even benefit the most from having taken calculus in high school. So the point here, kind of like what you said, is that taking calculus in high school could be the difference between passing the college calculus class and not. The framework misrepresents the very studies it's using to justify itself. And so added to this concern is the concern that the framework heavily references one author. So the framework cites one author 83 times, and it turns out to be one of the authors of the framework. And to put this in perspective, the next author is cited 13 times, and this is also an author of the framework. This issue with the misrepresentation of citations is actually a very significant problem. With Brian Conrad's point, The framework never discusses inconsistencies in the math education literature. That is irresponsible when citing papers as a basis for public policy, because then it becomes difficult to distinguish evidence-based guidance from ideology. And so
Right.
this is a very, very important point, because one would hope if you're changing education of 6 million kids, it's going to be evidence-based and not ideology. And so this characteristic of misrepresenting literature, it was a huge problem in the first draft, and it continues to be a problem in this next draft. And it appears that these authors, they really don't care, because once they realize this becomes public policy, then at that point, whether it was evidence based or not becomes irrelevant. And once this framework passes, they're going to have political justification, which means do this because the framework says so. So no longer will they go and try to figure out whether it was right or wrong. And now you have districts that are going to receive funding because they're perhaps following and adopting the framework. And so, it's a very dangerous situation that will unfold once this happens. And again, the bottom line, there is no data that says that for a kid who is prepared and motivated to take Algebra 1 in 8th grade, that holding them back would be beneficial. Someone told me I need to create a comic to try to demonstrate some of the things I'm talking about. And so now here I'm using my great artistic ability, right? I'm being completely sarcastic. But I'm trying to show here how the foundation of math as a student goes up through their courses, and how important it is to develop this foundation. So on the left, we have this foundation built on the learning all the math standards. And so you have a student climbing up the staircase. They get to the top and they're really happy. They have their AP calculus. The door to the STEM career is open, and their first year of calculus, they're able to place out, and they're able to continue on through the ladder onto a STEM career. So then on the right, you have a district that adopts the framework, where standards that you have in yellow, the standards that the students just didn't wonder about. And then in pink, you have the standards that they were just avoided coverage of. And so now you have that is a staircase that's built upon a very weak foundation. So the student gets to the top, the foundation is not strong enough, and then it doesn't support them. They're not ready for the STEM career. They fall off, and they fall down, and they find out they just simply were not prepared. And what can they do now? And that the State Board of Education misled them, and the State Board of Education told them that this was best.